All right, so like I said, today we are working on chapter 7-1 on graphing systems of equations. So basically, chapter 7 is we're going to learn 3 or 4 different ways to do the same thing. So when it comes to your chapter 7 test at the end, you can do any of the ways we talked about in the chapter. But like I said, we're going to learn 4 different ways to do the same thing. And then 7-5 is very similar to 6-6, so that'll be different. But we're going to go over this. This week we're just doing 7-1, 7-2. Okay? So today you're going to have 3 types of lines. You're going to have intersecting lines. An intersecting line is a line that crosses each other. They have one solution. So when you have 2 lines that cross each other, you're only going to have one answer. Okay? Same lines is when we graph it, the 2 lines are going to be overlapping each other perfectly. Like they're going to be the exact same line. That is going to have infinite solutions. So if you run into that today, all you have to do is put an infinite sign, which is a sideways 8. And then the last type of lines we're going to have is parallel lines. When you graph them and they're parallel, meaning they're never going to touch, you're going to have no solutions. So you're either going to have one answer, have an infinite sign as your answer, or you're going to put no solution for your answer. Okay? To graph them, remember we have to get them into y equals mx plus b, meaning the first thing you got to do is get x on the right side, and then you got to solve for y. Okay, once you have that, you graph them, you'll see what I'm talking about. So if we're graphing this first one, x equals -3 and 2x plus 1. First off, x equals graphs. Remember, you just go to that spot on your x value, so x equals -3, 1, 2, 3. And if you think about this, it's saying my x value is always going to be -3. So that is why x equals -3 makes a vertical line, like that. And then we have y equals 2x plus 1. So where do I put my first dot on 2x plus 1? At the 2 or the 1?
2.
At the 1. So you go up to 1, put a dot. And then from there, you're going to go up 2 over 1 the whole way through. Now, what I'm going to suggest, the more dots you put, the better it is for you. Okay, because we need this thing to be as accurate as possible. So I'm just going to keep going up 2 over 1 until I run off the graph. And then I'm going to go the other way. Because like I said, I want this to be as accurate as possible. Okay, so that is what our 2 graphs are going to look like for the first one. That's x equals -3 and 2x minus 1. So as you can see from these lines, are they intersecting, are they the same line, or are they parallel? They're intersecting. So our answer is going to be where they cross each other, which would be this coordinate right here. So -3, -1, 2, 3, 4, -5. So your answer for number 1 is -3, -5. And that's all you got to do. So today is a lot of graphing. Okay? So then you look at the second one. First thing we got to do is get y by itself. So how do I get x to the right side? How do I move a positive 1x? Minus. So then I'm going to have y equals -1x plus 3. And then I can cross out that equation because I won't need it anymore. And then the same thing here, the -1x. So then I have y equals -1x minus 3. Won't need that equation anymore, so I can cross it out. And we're going to graph them. So where do I put my first dot on the top equation? At -1 or at +3? 3. So we go up 3, 1, 2, 3. And then we're going to go down 1 and over 1 the whole way through. And like I said, the more dots you put, the more accurate your line will be. That. Then we're going to graph our second one. I put my first dot at -3. So I go down 3, 1, 2, 3. Down 1 over 1. So there are my 2 graphs. So are they intersecting, are they parallel, or are they the same? Parallel. So if they are parallel, that means they will never cross, they will never touch. So my answer is no solution, which would be a 0 with a line through it. So that's number 2. Okay, so now for number 3. First thing I do, I got to get x on the right side. So how do I move a 2x to the other side? Minus, so then we have negative y equals negative 2x minus 3. And then how do I get rid of that negative 1? What's the opposite of multiplying? Dividing. We're going to divide by negative 1. So y equals 2x plus 3. So that is this one right here. 2x plus 3. And then we got to do the same thing to the next one. So I'm going to minus the 4x. Negative 2y equals negative 4x minus 6. Divide by negative 2. So y equals 2x plus 3. So what do you notice about these two equations right now? They're the same. So when I graph them, 1, 2, 3, up 2 over 1, up 2 over 1. When I graph them, they're going to be the exact same equation overlapping. So they're going to touch infinite amount of times. Because you think, if I graph the first one in red, or in blue, sorry, and then I graph the second one in red, they're always touching. Okay? They're like two immature 8th grade boys that can never stop pushing each other. They're always touching each other. So this would be an example of infinite solutions because our equations are the exact same. So those are what the 3 examples, what they're talking about today. So do a couple more, then I'll let you go. So first off, do we have y by itself in both these equations? So we can graph them right away. First dot goes at negative 4. 1, 2, 3, 4. I'm going to go up 3 over 1. 1, up 3 over 1. So here's my first equation. And then my second equation, I'm going to go down 3 over 1. So are these parallel? Are they the same or are they intersecting? Intersecting. So then you just have to put for your answer where they cross each other, which would be right here, which is 0, negative 4. Last one we'll do right here. So, put a plus 0 right here. How do I get rid of that 3 right here? How do I get rid of multiplying? Divide. So I'm going to divide this whole thing by 3. So this is going to be y equals 2/3 x plus 0. So I graph them, go down to negative 5. 1, 2, 3, 4, 5. Up 2 over 3. Then do the same thing with the next one. Put a dot at 0. Go up 2 over 3. So what do we notice about these two lines? Parallel. So how many solutions are they going to have? 0. So your answer would be no solution.